In this video, we're going to look at how recomposition works underneath the hood. Recomposition has three goals. We need to be able to traverse the slot table to find a group with the recomposition scope that needs updating. We also need to skip groups that don't need updating. The way we update the slot table is through something called a changes list. We're going to look at during recomposition how that changes list gets created. Let's start with an example. We looked at previous video, this example, and we looked at what happens during initial composition. So suppose in this example, if I were to change the value of name from Bob to John, this greeting method is going to get called again. What happens when it gets updated? When we had set up compose, we had set up the recomposer to listen to changes by hooking into the snapshot system. By using this method, we were able to set up an observer. And this observer, what it gets is a value of changed. And what is changed? In this case, the invalidation is the mutable state with the new value of John. So inside of this method, the recomposer then has to recompose and has to create a changes list. And here is where we have to traverse our slot table. So this is what the slot table configuration looked like after initial composition. This is what the group address space was, and the reference slots have recomposition scope instances for some of the groups. So we need to be able to traverse down. And the question is, well, when you traverse down, how do I know which group to stop at to be able to take its recomposition scope and compose it again? Well, we're going to use a concept that we saw before, which is a group flag. So the composer, what it gets during recomposition is a map of invalidated recomposition scope instances. And this is really useful because what those recomposition scope instances have is the group address. So we're going to tell the slot table reader, hey, go to this group address and then set this is recomposition required flag. So this is like setting markers for the groups that need changes. That's what I'm doing with this flag. And this is why it was useful to add that group address to the recomposition scope. So when this happens, you could see all of the groups that need changes, there's a flag that gets added to them. The next thing, we need to traverse down the groups in the slot table from the top to the bottom. And we're going to do this through an extension called traverse groups requiring recomposition. And this is an extension inside of the source. And what it gives you is, as it's traversing down from the top to the bottom, it gives you the group instance. So I could use this group instance and check if it has a flag that I had set earlier. And basically, I'm going to grab the recomposition scope from that group, and I'm going to call compose again inside of it. That recomposition scope, what it internally has is state. And what is the state that it has? It has basically an instance of the scope. Basically, that I had set in the generated code. So when I call compose again, what happens underneath the hood is that it's going to start to basically call this greeting method again with new values. And the value that gets updated is the name value. And what that change value right there represents is basically param states. And this is set in the compiler plugin. And we'll look at more in detail in the compiler plugin, Compose compiler plugin video series. So what it represents, that change, is a set of param states like same and different. And same and different have different like bit values. So the composer, we're going to call the change method. We're going to provide it the new name value. And in there, we're going to update the slot table by creating a changes list. So how is that changes list created? So internally, what the changed method does is that it goes in and compares the cached value in there in the slot table, and it calls this update value method when there is a change. And what this update value method does is that it creates a changes list. And what a changes list internally is a particular type. And it's basically a seal type, and it has 35 operations. And these are all the different changes that you could do in a slot table. You could traverse, you can move things around, for example. And what I need to do is to create this changes list just like this. And in this example, I'm going to update a value, and the value that I'm going to update is that slot address to, which is the new value right there. So when this method gets called, it doesn't immediately change the slot table. It does it at the end by basically collecting all these different changes. This is one change we have so far. So as this method, as we're traversing down each of the composable methods, some of these composable methods don't really need any recompositions, and we need to be able to skip them. And that's basically where the skipping logic that's generated comes into play. And when we go to another composable method that doesn't require any changes, that could be skipped, we basically call this skip to group end method right there. And this is telling the composer that I need you to skip this group as you're traversing down from the top to the bottom. So what that does is that then we go to the next composable method, which also doesn't require any changes, which gets skipped. So ultimately what you have now is basically the group that required changes. You could see that the reference slot right there got updated. The value of hello got updated right there. The greeting value got updated. That's what that change was. And in the end, it will basically collect all those changes and then apply them in a batch. When it goes and applies those changes in the changes list, it also tells the applier. That's what the purpose of the applier is, which is what you provided when you had set up compose. And what it does is that it basically tells you it tells you when updates are being done. There are callbacks that get fired in the applier. And what you could do in there is traverse the tree. In this case, it's the UI tree, but it could be a different context in which you're going to update the value of hello John. So the slot table got updated, and then it told you through the applier that I need you to update your own context. So these are the methods that would get fired in this example if you had something like a node applier. So which is what Compose UI has, for example. In here, basically you have on begin changes. Those are methods that will get called when it starts to apply all those collected changes. And then it will call insert top down when it tells you to update a particular node. So in the end, when all the changes are bashed together, this is what you're going to see. This is the method that applies those changes. Just as we saw before, it's using the editor on the slot table, and it's taking in all those changes and applying them one by one to update the slot table. So you don't always need an applier. It's all contextual. So in Compose UI, you need an applier because you need to update the UI tree. But if you look at how Molecule sets up Compose, Molecule in that use case, it has an applier, but it doesn't have any logic in it, just a unit applier. Because in this case, in this example, you don't need basically an applier. You don't have an external tree that you need to update, for example, in this case. So it's all contextual, but the same pattern applies in terms of how Compose is set up. So this is a very simple example of what happens underneath the hood in Recomposition. There's three goals. One is to be able to traverse the slot table to find the group. We need to find the group that has a recomposition, is required recomposition flag set. We need to create these changes, the list of changes, to update it. And these are the three goals that basically we looked at. If you want to learn more about what happens with Compose underneath the hood, especially at the compiler, what the compiler plugin does. If you want to look at more what happens underneath the hood, also with performance, you could look at my KotlinConf talk called Guide to Improving Compose Performance. I hope that was helpful for you. I hope you learned something from that. If you want to learn more about coroutines or Compose, check out my website, codingwithmohit.com.